Okay, so we're going to do this question in two different ways because you'll get the same answer, but there's just two different methods that you can use for the implicit differentiation. So method number one, we're going to be rearranging the formula in terms of y equals. So 2ex minus 3y squared plus 3 pi squared is equal to 2e. So in order to get this in terms of y equals, the first term I'm going to move across will be this one and this one. When I take them to the other sides, they'll change symbols, so they'll become minus. So minus 2ex minus 3 pi squared. Okay, next thing we'll move across is the negative 3. So we're going to divide each term by negative 3. Now I'm going to keep them separate just to make it a little bit easier when we derive. And then I'm going to take the squared across by square rooting this whole thing. So that's going to leave me with y is equal to, now the next thing I'm going to do is I'm going to put it in brackets. And instead of writing it as the square root symbol, I'm going to write it as to the power of a half to make it derivable. Now, this one will simplify to become a positive. And this one here, the negative 3's will cancel out and it'll just become 1. So I'm just going to write that as pi squared. Okay, and it's all to the power of positive a half. So now to use implicit differentiation, I'm going to take the derivative of both sides with respect to x. So dy over dx, d over dx there. So this side will be left pretty much as it is, dy over dx. And you'll get a bit more about why this works when we go through this question in the second way. So dy over dx is equal to, now I'm going to apply chain rule for this one. So the derivative of the inside of this bracket, the only x that's there will be this x here. So that's the only term that's going to come to the front. Now if I derive this, because that's got one x above it, the derivative of that power above will just become 1, meaning that it looks like it hasn't changed. But we did take the derivative of it. Okay, so the derivative of the inside multiplied by the derivative of the outside of the bracket. And I'll put this back in the bracket, 2e over minus 3 plus 2e x over 3 plus pi squared. So next thing that I need to do is let x equal 1. And I don't have any y's that I need to substitute this pi into at the moment because I've separated it out into dy over dx is equal to this. So if I substitute that in, we're going to go over to our graphics calculators. Now I'm substituting in 1, so the power above it is just going to be 1 times a half, bracket 2 power of 1 over 3. Oh, forgot the negative bit there. You could fast forward through this part where I'm just typing in the calculator. Plus 2 plus pi squared, close bracket, all to the power of negative a half. Okay, now I'll press execute and you'll see that my answer is 0.2884, yada yada. So that will go closest to this one here, 0.29. So C is our solution. So that's option 1, getting it in terms of y equals first. Your second option that you can do is you take the derivative of each term with respect to x. So d over dx for the first term minus, and we take the derivative of the second term. I'm going to separate them with a plus symbol because they're separate terms. So d over dx for the next one, 3y squared, or minus 3y squared, plus d over dx. Now this one's got no letters in it, which means that when we derive it, he's just going to vanish, is equal to d over dx of 2e. Okay, pretend like I've got more space and I wrote that out nicely. So now I'm going to go through and I'm going to take the derivative of each of the functions with respect to the x variable. So for this one here, when I derive the top, the 1 will come down and multiply the 2. So that will be left as 2ex. For this next one, I'm going to derive the y variable. So minus 3y squared will become dy, because I derived with respect to the y variable, minus 6y. The next one doesn't have any variables at all. So it's just going to be 0 and it's going to be equal to 0. So having this section there, the dy over dx, is the trick with our implicit differentiation. This is the function for the gradient formula, which is why I had to derive this and take one of the y's out so that I could get this part here. Now I want to make the whole things in terms of dy over dx is equal to everything else. So to be able to do that, I'm going to take the 2ex to the other side first, and that'll make that minus 2ex, which will leave me with dy over dx multiplying minus 6y, which means that to take this across, we're going to divide the whole thing by minus 6y. So minus 2ex over minus 6y is equal to dy over dx, or the gradient formula. So you can go through and simplify that out further. It would become a third, or you can put it straight into the calculator over here. Whatever you do, you'll still get the answer of 0.2884, which proves the answer of C.